So this video is to give you tips and tricks on how to make a spreadsheet in Excel that is going to do all your calculations for you. So right now you're looking at a template for the acceleration on an incline experiment. Now your lab instructor may or may not give you a template spreadsheet, but even if they don't, that's okay. Because even though this looks really fancy, it's actually a completely empty spreadsheet except for the labels. So either way, you're going to have to type in all of your data and type in the formulas that will allow Excel to calculate your values for you. So you're going to be doing all of the brainy work. Now in this template, I will just point out that up here at the top, there's a measurements section, and this is where you would type in all of your raw data that you measured in the experiment. And scrolling down below, we've also got a calculations section. So this is where you would type in the formulas that would calculate your final values from your raw data. So calculations at the bottom, measurements up at the top. And one thing that I'll point out to you right now is that you'll notice up here that I've got, for example, the width of the flag, the initial position of the glider, and the final position of the glider. If you scroll down to the calculations section, you see these three things again: width of flag, initial position, final position. And why is that? Why do they appear in two places? Well, the units down here are in meters, and up here at the top, they're in centimeters. So what that's meant to imply is that we do want you to do your conversions in Excel. I'll show you this later. Now, the first thing you would do with your spreadsheet after you've typed in all of your labels is that you'd also want to type in your raw data from your experiment. So I'm going to use a little bit of video trickery here to do that. So there's all my raw data, and now I'm ready to start typing in some calculations. So the first one I'm going to do is that over here, you'll notice that I don't have uncertainties listed for the time measured by my photo gate. And that's because the uncertainty of a photo gate is 1%, so I need to calculate those uncertainties. So I want to calculate 1% of each of these times that I measured. I click into the correct cell, type equals 0.01 times the time that I measured. And that's going to calculate 1% of that value. And of course, I can then copy and paste this formula downward for all the rest of them. The next thing I want to talk about is you'll notice that on all of the data, I've got this third column on everything. So every piece of data has this third column. And what's that about? Well, right here, I've got the data value. Right beside it, I've got its uncertainty. And this third column is the fractional uncertainty of it. Having the fractional uncertainties is going to be useful for two separate reasons. First of all, when you write up your discussion in your typed report, you're going to need to do what's called a precision analysis, and the fractional uncertainties are really useful for that. The other thing it's useful for is when you do more complicated uncertainty calculations, you often need the fractional uncertainties, so it's really helpful to have those already calculated. And you're going to see me using these later in this video. So let's calculate one of these fractional uncertainties. So I've got the value here, its uncertainty right beside it, and so the fractional uncertainty would be equal sign, the uncertainty divided by the value. Hit enter, and that's my fractional uncertainty. Now, I want this calculation to appear everywhere in the spreadsheet. It's all over the place. And it would be nice if I could copy and paste this formula everywhere all at once, and there is a way to do that. But first you need to learn how to make a multiple selection. So what I mean by that is, can I select more than one cell at the same time? Yes. What you do is you click a cell, you hold down the Control key on your keyboard, and then you can start selecting other cells, as many as you want. So we're going to use this to copy and paste this formula everywhere in the spreadsheet all at once. So the way to do this is, first, I start by clicking that cell where the formula appears that I want to copy and paste elsewhere. I go up to the clipboard area on the Home tab and click Copy. That gives me that blinking outline. And now I'm going to click another cell where I want that formula to appear. And then I use this multiple selection trick. I hold down the Control key and I start selecting other cells where I want that same formula to appear. And I've got some down here at the bottom as well, so I'll go and do those as well. Again, hold down Control and click all the other cells where you want the formula to appear. And I think that's all of them. And so now, again, I go back up to the clipboard area on the Home tab and I click Paste, and it fills in all of my formulas for me. So anywhere that there's already data appearing, I've already got a number. Down here, where there is no data or uncertainty yet, I'm getting an error message, but those cells will fix themselves when I do have data typed into these cells. So these will fix themselves, and these ones are already set up. So now I'm ready to do some more calculations. So I'll scroll down to my calculations area, and the first calculations I want to do are going to be the averages of the travel time of the glider and how long the photo gate was blocked for by the glider's flag. So I want to calculate the average of something, and Excel has a formula for that. So I'll just type equals average, open the brackets, and now I want to input a list. So I can come up here to my data and just click and drag to select all of that data, scroll back down, close the bracket on average, hit enter, and it calculates the average value of all of my data up here. So I want to do the same thing over here, but it's going to be the same calculation, which means I should be able to just copy and paste this formula sideways, and it'll automatically update to use all of this data instead. So that's what I'll do. I'm going to highlight this, copy it, that gives me my blinking outline, click into this cell, and paste that formula. And it's correctly calculated the average of all of my data up here. So now I want to calculate the uncertainty of that average. And remember that an uncertainty on an average has nothing to do with the uncertainties on the individual data values up here. Instead, we're going to use a statistical uncertainty, which is based on how much this data varies relative to one another. So just as a reminder, this is the formula for the statistical uncertainty of an averaged value. So this is what I need to type in here. So I type in equal sign 2 times, and now the sigma symbol is standard deviation, so STDEV to get Excel to calculate the standard deviation. Open the brackets, and here inside the brackets I want to put my data. So not the uncertainties, but the data, because the standard deviation is a measure of how much the data values vary relative to one another. So I scroll back up, and I select all of my data again, come back down, close the bracket on the standard deviation, and now I want to go divide by square root of the number of data values that I have. So SQRT for the square root, open the brackets, and N is going to be 20 because I have 20 runs, but you don't actually need to remember that because there is an Excel function to just count up how many data values you have in a list. So I'm going to use that instead. I'm going to go count, open bracket, and if I highlight my data again, it's going to count up how many data values I had. Scroll down, close the brackets on count, close the brackets on the square root, hit enter, and there's my statistical uncertainty on my averaged value. And again, this formula is something I should be able to just copy sideways. So I'll do that now. Click the cell, copy it, click the other cell, paste it. The next thing I'm going to work on are going to be these conversions. I want to convert those all into meters, and I'm also going to do the calculation for the displacement of the glider. So I have got all of my raw data up here, and I want to convert from centimeters to meters. So I'll click into one of these cells, and I'll do this one first. I go equal sign, come up here, find the right value, click on it, come back down, it's filled it in for me, A11, and then to convert to meters, I just divide by 100, hit enter, and that's my converted value. Now the uncertainty will also have the same conversion, so I can just take this guy, click and drag sideways, and that fills in the conversion for my uncertainty on the width of the flag also. You'll also notice that the spacing and position of all the data up here is identical to the position and spacing of all of these values here. And that's on purpose so that you can just say, you know what, if I take these guys, copy them, select this, hold down the control key, select this, I can just paste those formulas in also. Because the spacing of all of these cells was identical to the spacing of all of these ones, that works. So the template spreadsheet was set up intentionally to make things a little easier for you when you need to copy and paste these formulas. So those are my conversions into meters, and now I'm going to do the calculation for displacement of the glider down here. So this is just a subtraction, so equal sign, position 2 minus position 1. Hit enter, and that's my final value. To get the uncertainty here, I'm going to need to use the addition-subtraction rule of uncertainty propagation. So just as a reminder, if your calculation looks like this, then the uncertainty looks like this. So it'll be the square root, and inside the sum of the squares of the absolute uncertainties of position 2 and position 1. So let's start typing that in. Equal sign, SQRT open the bracket, and I want the absolute uncertainty of D2, which is right here. I click on that, I square it, so caret symbol 2 to square it, plus, and then I want the absolute uncertainty of D1, so I click on that, caret symbol 2 to square that, close the bracket on the square root, and that's my uncertainty. So the last thing I'll calculate with you is this first acceleration value. So the calculation for that and its uncertainty, I will leave the last two acceleration calculations for you to do. The formula for A1 is 2d over the square of the time it took the glider to travel a distance d. So let's type that in now. And I would type in equal sign 2 times, my distance d is here, so I click that cell to fill it in, divided by, and I want the average TD value, so that's here, and then I square it, caret symbol 2, hit enter, and that's my final value. So the uncertainty calculation is going to be a little bit more complicated than this. So if this is our value, then the uncertainty is this. So it'll work out to be final answer times the square root, and then inside the square root, you have the sum of the fractional uncertainties squared, except that for TD squared, you will need to apply the roots and powers rule, and in here, the fractional uncertainty of TD squared actually has some cancellations, and it winds up simplifying to just this form, 2 times the fractional uncertainty of TD. This is something you'll have to work out for yourself, but with some simplification, this is what the uncertainty looks like, and that's what we need to type in here. So let's do that. So we type equal sign, and I've labeled this as 2d over td squared, but this is just the final answer. We don't need to actually calculate this all again. We can just use the value that we already calculated right here. So I'll click on that, and that's my 2d over td squared times sqrt for the square root. And here's where the fact that we have fractional uncertainties calculated all over the spreadsheet is going to pay off. We want the fractional uncertainty of the total distance d, which we already calculated right here. So I'm going to click on that and square it, plus, and I'm going to need some more brackets here. So open bracket, 2 times, and now I want the fractional uncertainty of TD, which again, I already calculated here. So I click that cell, close the brackets, and square it, close the brackets on the square root, hit enter, and now I've got the uncertainty of my first acceleration. And I want to point out that you simplify things quite a bit when you use the final answer that you already calculated and the fractional uncertainties that you already calculated to make it a little easier to type in this fairly complicated expression. And it's wise to do that just because it's easier to troubleshoot. If you have a little typo somewhere, it's easier to find if you kept your formula visually very simple like this. So that's the first acceleration value. And as I said, I'm going to leave A2 and A3 for you to calculate, and involved in that, you'll also need to calculate the final velocity of the glider. So I'll leave those calculations for you. You should go back to the uncertainty calculations that you did last week, and you'll fill in each of these formulas and have Excel calculate your final values for you.